Alright, so we're going to do some practice problems of finding the limits. So 1a, we've got the limit as x approaches negative 2 of the fraction x plus 2 over x squared minus 4. And very quickly, if you try and plug in that negative 2, you get 0 over 0. So that gives you some cause for worry. So what we're going to do is we're going to assume that since it's 0 over 0 that we may be able to factor this thing and work through it. So let's see, we'll rewrite it. Limit as x approaches negative 2. Of course the top doesn't factor, that's still x plus 2. But the bottom here, x squared minus 4, that'll be x plus 2 times x minus 2. And when you do that, you can cancel the x plus 2 out of the top and bottom. So it simplifies a little bit to be the limit as x approaches negative 2 of, now don't be tricked, the top is now reduced to 1 over x minus 2. So now if you plug the negative 2 in, you get something that works. You get 1 over negative 4. That means negative 1/4. Okay? So the limit as x approaches negative 2 is negative 1/4. The next one, the limit as x approaches 7 of the square root of 12 plus 5x. Okay, so you can try and plug this number in and see what happens, and I think everything goes well. So if we do that, we get 12 plus 35, which is the square root of 47. Well, it's not the best number in the world, but it does work out. So when you plug in, there's not a problem. And the square root function is continuous on a huge interval, so we could check the domain if we like, but obviously 7 worked. So the answer would be square root of 47. The next one, 1c, the limit as x approaches 0 of the fraction numerator x squared minus 5x over denominator 2x. So we plug in 0. We get 0 over 0 when you evaluate that. So let's see if we can break it down a little bit. We'll have the limit as x approaches 0. We can pull an x out of the top, so it'll be x times x minus 5 and the 2x on the bottom. So when we do that, we're able to cross an x out of the top and bottom. So it simplifies a little bit to be the limit as x approaches 0 of x minus 5 over 2. So that gives me negative 5/2. So if you were to graph this thing, you would be getting close to negative 5/2 as x became 0. Alright, let's go down here and try and do a few limits from graphs. So we've got this big old graph here. It's got a bunch of breaks, points all over the place, but let's see if we can evaluate what we've got. So the first one is limit as x approaches negative 4 from the positive side. So here's negative 4 in the middle. And if we come at it from the positive side, it looks like we're going to hit negative 2. Okay? Negative 2. Now, part B, as x approaches negative 4 from the left-hand side. So if we try and approach negative 4 from the left-hand side, it looks like we're going to have a y value of 3, and that's fine. The next one, x approaches negative 4. So we just answered kind of our own question, but if we come from the left, we get 3. If we come from the right, we get negative 2. So let's go back and fix that 2 to a negative 2. Sorry about that. But since they do not match, this will be a does not exist. We can't have different answers from the left and right. D, x approaches 2. Well, that means it has to match from the left and right as we just saw. So 2 from the left is going to negative 1. 2 from the right is going to 5. So as we try to zone in on 2, we get different answers from the left and right, so it does not exist. E, f of 2. So we look for where x is, and when x is 2, we see a closed circle down at negative 1. So f of 2 is negative 1. F, the limit as x approaches 2 from the positive side. So I'm not sure that we did that exactly, but approaching 2 from the positive side, it looks like we would hit 5. That's the expectation. There's no point there, but it looks like we're going to run into a y of 5. G, as x approaches 4, where's 4? Over here. As x approaches 4, you come at it from the left side, it looks like you're going to hit 2. You come at it from the right side, it looks like you're going to hit 2. They match, so they both give you 2. H, f of 4. So f of 4, when we look at 4 here, it's an open circle. We look up, we look down, we don't see a value. So we don't see a given value for when x is 4, so it does not exist. Alright, the last one here, I, the limit as x approaches -1. So here, -1's over here. So as we come out from the left, it looks like we'll hit 4. Come out from the right, it looks like we'll hit 4. It's a nice continuous function. So that limit would be 4. Okay. Then we got a couple problems here from algebraic functions. So we're going to find the domain. The first one, A, is the limit as x approaches 9 of the square root of x plus 7 and then minus 4 all over x minus 9. So if I plug 9 in there, I get square root of 16, which is 4 minus 4 over 9 minus 9, so I get 0 over 0. So we're going to handle this with a conjugate. So we'll take the x plus 7 minus 4. Let's clean that up a little bit. It says it's erasing, but it's not happening. There we go. X square root of x plus 7 minus 4 all over x minus 9. So we're going to use a conjugate to try and get this out since we got 0 over 0 and nothing looks like it'll factor. So we're going to multiply the top by x plus 7 plus 4. That's our conjugate. And we'll multiply the bottom by the same thing because we can't change the value, so we can only multiply by a 1. So as I do that, the top becomes x plus 7, and we're creating a difference of squares, so there's middle terms, square root of x plus 7 times 4, and there's another middle term, -4 times the square root of x plus 7, so the positive 4 and negative 4 quantities cancel out. And then -4 times positive 4 is -16. Now on the bottom, we don't really need to distribute this, so let's kind of keep it separate. X minus 9 times the square root of x plus 7 plus 4. So let's clean that up a little bit. We'll have the limit as x approaches 9. A little bit messy down here. Of numerator x minus 9 when we clean it up. Denominator x minus 9 times square root of x plus 7 plus 4. So we can cancel out that x minus 9 on top and bottom. So now we can plug in the 9. So let's scroll down a little bit to give ourselves a little bit more room. Not too far. So when we plug in the 9, we get 1 on top because everything reduced. And on the bottom we'll have square root of 16, which is 4 plus 4. So it looks like the limit is 1/8. Okay. So that conjugate allows us to simplify something that is 0 over 0 where it wouldn't factor originally. B is limit as x approaches 4 of numerator x squared minus 6x plus 8, denominator x squared minus 3x minus 4. We plug in the 4, we get 0 over 0. So we're going to try and factor. So we got limit as x approaches 4 of x minus 2 times x minus 4. And on the bottom we will have, it looks like x minus 4 times x plus 1. So while the 4 is a problem there, it cancels out. And the terms that are left, we'll plug the 4 in and we'll get 4 minus 2 on top, so we'll get 2 on top. 4 plus 1 on the bottom, we get 5. So after the domain problem is canceled out, in this case, we get the limit is 2/5. C, we got the limit as x approaches 2. The fraction, the numerator 4 minus the square root of 18 minus x over x minus 2. And so if I plug the 2 in, obviously I get 0 on the bottom. But if I plug 2 in on the top, I get 4 minus square root of 16, which is also 0. So I'm going to use the conjugate idea again. So 4 minus square root of 18 minus x all over x minus 2. So I'll multiply that by 4 plus the square root of 18 minus x all over 4 plus square root of 18 minus x. So multiply the top out, it looks like I get 16 minus the quantity 18 minus x, so we'll clean up in a second. On the bottom we got x minus 2 times 4 plus the square root of 18 minus x. So the top becomes, when we clean it up, we'll just go ahead and put it back in limit. Limit as x approaches 2. The top becomes 16 minus 18, which will be negative 2, and minus times minus x, so the top will become x minus 2. And that's good because we see the x minus 2 factor on the bottom. Now if you try and multiply these bottom parts together, it makes your life more difficult. But that's still times the conjugate that we created, 4 plus the square root of 18 minus x. So we can cancel out a common term of x minus 2 over x minus 2. And now we can plug the 2 in, and on top, since it reduced, we'll have 1. On the bottom, it looks like we'll have 4 plus 4, 1/8 again. I'm not sure why that happened, but it did. So we're pretty happy. All right, good job.